Show the mechanism of formation of 2-bromobutane from butane using free radicals. So free radicals is a big thing because it tells us the mechanism we are supposed to use. So which means let's write our reaction first. This is butane. And then this is 2-bromobutane. You can write the bromine on the left too if you want the same thing. In any case, so what is it that we need as our reagents? Okay, to go from butane to bromobutane is going to be, of course, bromine. And then because this is free radicals, we're going to need some light, or you can also use heat, okay, depending on what you want. So now remember that when you ever do free radical mechanisms, you need to have 3 steps in there, okay, and the 3 steps you need are initiation, propagation, and termination. Okay, so in case of initiation, you're going to prepare the free radicals. Propagation is where you can continue on your reactions. You must have a free radical in the product. Termination, no free radicals in the product. Okay, that's the important thing. So let's start with initiation. Do you have to do all these 3 steps all the time? Well, it's up to the question, okay, and what the question is asking you. Since we are asking here about the mechanism, it's a good idea, okay, to write all this. So how do you start the initiation? You generally start with bromine because bromine bonds are easy to break, okay, and so you start with bromine. And remember, you're doing free radical mechanism, so you need half arrows, okay, this arrow, not this arrow, okay. So once you do this, you get 2 bromine radicals. Okay, now this is the initiation step, and after that is going to be the propagation step. The most important thing about propagation steps is that you should have a free radical. Okay, so now the question here is very specific in asking you to make 2-bromobutane, okay, so which means that you have to work on the second carbon over here, okay, in order to make the product. In some cases you're left with your choices, like whatever you want to make, but in some cases it's very specific. So I wouldn't worry too much about, you know, what I should be doing, because either focus on the problem or just do whatever you want. Then if your problem is free, that, you know, you choose whatever product and just do whatever you want to do then. Okay, so here the other thing about bromine you want to make sure, okay, that's the second part, is that bromine radicals will always go to more stable carbon radicals. So more stable radicals, again, that's going to be just like the carbocations, that's tertiary more than secondary more than primary. Okay, so keep that in mind as you're working through your mechanism. So usually you will, you know, if you're asked to make something like, you know, 1-bromo, then it's a little unusual, because the 1-bromo, you know, that's not the best thing. Okay, so you have to find a different way to make it, because when you're using bromine, you're probably going to form a more stable radical, which is the secondary and not the primary. Okay, all right. That being said, let's continue on with the mechanism here. So now in this case, you have the hydrogen and the bromine radical. The bromine radical is going to come and pick up the hydrogen. Where do you write this arrow? You can actually write it anywhere. Just make sure that they're coming towards each other. And then the 1 electron from the hydrogen bond to the carbon, that's going on to the carbon then. And so that means you're going to have something like this. You also form HBr. Okay, so if you want to write HBr here, you can do that. You can also write that on the arrow. It's up to you. It doesn't really matter. So remember, since we are doing propagation, we need to have a radical in the product. So here we're going to start with Br and Br again, which means bromine again. And it doesn't matter if you've used bromine before, you can't use it again. Who says that? Okay, and remember that there are many atoms in 1 mole, okay, of butane and bromine. So no worries about, you know, how am I getting a second one? Well, we have plenty. Okay, so then you have bromine radical, okay, that's going to be formed here. Okay, because of this reaction. So in this one, you do 2 things at the same time. So you're forming your product and you're also creating the radical. Okay, over here. So that's your propagation step. Do you need to do anything more here? No, you don't. Not in the propagation step, because here is your product. Okay, so technically this is done. All right, but you also need to show termination. Now, in some cases, again, read the question carefully as to what it's asking. Usually your termination step can also be your final product formation. So let me write down all the termination steps you can have. So for example, one of the termination steps can be that if you had a bromine radical reacting with another bromine radical, then you can form bromine, and that would be a termination step. Okay, another step would be if you were to take this radical and treat that with the bromine radical. Okay, and then that would also give you your product as well as the termination step. Okay, both in the same things. So you can do it however you want. You have some flexibility in free radical mechanisms. Okay, but this is how you would write the mechanism for free radicals.